Hello, everyone. All right, let's go with a couple of the theorems that we talked about on Friday. Circle segment theorems. First one we'll talk about is intersecting chords, right? So remember the definition of a chord. It's kind of like a secant, doesn't go through, stays on the edges of the circumference. So the rule here is, the theorem here is A times B is going to be the same or equal to C times D. Okay, so here is the formula for that. And I've got a quick example for you. So go ahead, pause me, see if you can get the answer to this. I'll work it out very quickly. You thought, pause me. You didn't pause me, okay? So go ahead and try that one. Second one, secant, secant. So the rule here is, it's the whole first secant, meaning addition, right? Because you'll add this part to that part, times the outside part of that same secant. And that's going to equal the entire second secant, okay? This part plus this part times the outside part of that. And again, I've got another example for you here. So you can pause me or you continue to do this as I talk. And the last one, hopefully you can see that, secant tangent, okay? And that is kind of like the other ones, obviously, but the tangent part of this is only one section or one segment, right? So it's a squared, and that's going to equal the entire secant, so that part plus that part times c. So again, we're going to have to do quantities here if you end up with quadratics, which you are going to on all three of these, I believe, okay? So hopefully that's good for you. Let's go with a couple of answers, and I'll work these out really quickly. Just want to get a little bit of an eraser here. All right. All right. So for the first one, A times B, so we've got x minus 3 times x plus 3, all right? So x minus 3 times the quantity of x plus 3, and that's going to equal 8 times 5, which is 40, all right? So if I work this process out, I get x squared. Now, the plus 3x minus 3x, that's going to cancel out, right? So I'm just left with the L term here, so it's going to be minus 9 is going to equal 40. Plus 9 on both sides, and I'll have x squared equals 49. Now, quadratic, we're going to solve by taking square roots. Now, in this case, x is going to be plus n minus 7. But with regards to distance, right, real-time distance, we're only taking the positive value here, the positive intercept. So the answer here is going to be 7. Okay, so that's important for you to know when you ever solve quadratics with secant and segment theorems in the future. Okay, let's go to the second one. Secant, secant. All right. So the whole thing, and we'll classify this as, I guess, A and B, and then C and D, okay? So it's going to be the whole thing, and I wrote my notes down because I wanted to make sure that I wrote it correctly and didn't waste your time. Okay. So this is going to be 8 times 3, the entirety of this line here plus the outside, or times the outside, and that's going to equal the quadratic function of the entire thing added together, which is 2x minus 12, times the outside part quantity, which is x minus 5. So once that's FOILed out or multiplied out, I get 2x minus 12 times the quantity of x minus 5. Okay. So working this process out, I get 24 equals 2x squared. And again, I'm simplifying as I go. Minus 22x plus 60. Or, simplifying further, 2x squared minus 22x plus 36. Do yourself a favor here. Don't go through the grouping process. I mean, it works. The quadratic formula will also work. But what do these three terms have in common? They all have a 2 in common. So factor that part out, right? So then you'd be left with x squared minus 11x plus 18. Factor it by inspection. You know you need an x and an x. I know I need a 9 and a 2. And they both have to be minuses. All right, they have to be subtractions because I need to add them together to get negative 11, but multiply together to get positive 18. Now, if I solve for x here, I get 9 and 2. Well, I only want the 9. I want the biggest number, okay? I want the largest number, the largest distance in the continuum. Like this one, I need the positive value. This one, I need the biggest value, okay? And then the last one over here, we'll talk about secant tangent. Okay. So a squared is going to be the quantity of 2x plus 4 squared, which is going to give me 4x squared plus 16x plus 16. Okay, and that's going to be equal to the whole secant times the outside section, and that simplified will give me x squared plus 25x plus 100. Now, I like to shift everything over when I go with a negative here. I don't want to have a negative 3x squared. I'd rather have a positive. So combining like terms, I'm going to be left with 3x squared minus 9x minus 84. And again, do yourself a favor. If you see that all three terms have something in common, please factor it out. The 3 comes out of everything, and I'll be left with x squared minus 3x minus 28. This can be factored by inspection, because the 3's gone now, right? And I'll have the quantities of x minus 7 and x minus 4. And again, my values are 7 and 4, right, my intercepts, but I'm looking for the largest intercept or the biggest value, okay, for distance. Hopefully that clears things up a little bit for you. See you tomorrow. Bye-bye.